Finish him. Kill the guy now. You have to come. What? What is this? Good day, sir.
You are watching Jackie Pan in my house.
No, it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough like you'll be fighting kung fu in your dream. That's the reason why you have F's in your courses like especially made for you.
I have you last semester.
We £5 on you. Very stupid though. Yeah, change that section to ACTV right now. And oh God, the baby wants to have the first born. Stupid boy.
Good afternoon, everyone, and you are welcome back to MTA 201 online lecture. Last week we started the test for convergence of series, and this afternoon we want to continue. Last week I mentioned that there are 4 types of tests. The first one is integral test. The second one is Taylor ratio test. The third one is n-truth test, and the last one is Leibniz test. We started the integral test last week, and don't forget when you are given the function and what you need to do the series, you have to change it to integral. If you want to change it to integral, you have to change the function of n to x. So even if I give it function of k or anything, then you have to change the x so that you will integrate that function with respect to x. Let me discuss one more example on integral test. Integral test. Example 2, I discussed an example last week. The question says, show by the integral test that the harmonic series is in this form 1 over n diverges. Yes, we want to show that that one diverges. Is an harmonic mean. Then the solution. Harmonic series is of the form this brother, n to infinity 1 over n. So if that is the harmonic series, what we need to do is to change this function of n to functions of x. Then, don't forget, if my f of n will not be equal to 1 over n, then my f of x will be equal to 1 over x. Then, if my f of x is equal to 1 over x, we change this one now, this series to integral 1 to infinity of 1 over x dx. When you integrate 1 over x dx, you get log x. Then the limit of integral is from 1 to infinity. In that case, I will substitute the limit. I'll get log, I'll get log infinity minus log 1. Even if I change my infinity to n, let me change my infinity to n to do away with confusion here. I'll still come back to change that n to infinity. Don't forget that log 1 is equal to 0. This one will give me basically log n in a natural base. Then if I take the limit as n tends to infinity, then log n will be equal to infinity. So if I take this n as very big number, it will tend to infinity. And this one tends to infinity, then I say the function, the series is divergent. So that is just the proof of that one. The series is divergent. Now let us go to Broad-Lambert. The Lambert ratio test. Yes, what is Broad-Lambert said? If I have series un, u1, u2 to infinity, don't forget this one continue. I can write it as the sum of n is equal to 1 to infinity of un. This is the series given to us initially. But don't forget, for every big number, every large number, there must be at least a number that is larger than that number. Mention any number that is very big. I will tell you at least one that is bigger than it. That is what Broad-Lambert said, that if you are given a very big number to infinity here, un, I can move a step forward. I can add 1 to that number to make it bigger than this. If I have it to make bigger than that, don't forget, that one will give me n is equal to 1 to infinity of un plus 1. Then I will have that brother. Don't forget, this one is larger than this. In that case, Broad-Lambert now worked on these two series. This one was given to you. You will assume that there is one that's bigger. Then Broad-Lambert worked about these two functions. Then what does he say about that? He says if you are given that one, then that series, this series, the series is said to be converges. If this series will converges, if the absolute value of un plus 1 over un is less than 1, then is diverges if the absolute value of this brother over this plus 1 is for n over un is greater than 1. If the absolute value here is less than 1, then the series converges. If the absolute value is less than 1, is greater than 1, then the series diverges. Now, it is very difficult to use the Lambert theorem, the ratio test, to determine the point of convergence or divergence of any series if this function, this term is equal to 1. If this is equal to 1, I told us when if a function is neither diverge or converge, then it is oscillatory. But if this, you want to use the Lambert theorem, you cannot determine either the function converges or it diverges if this term, this absolute value is equal to 1. And in another case, the Lambert theorem, the Lambert ratio test can never be used to determine the convergence or otherwise of harmonic series. The harmonic series. So the Lambert theorem cannot use. But if that means, don't forget, the harmonic series I wrote that day was given of the form n is equal to 1 to infinity of 1 n raised to power p. That one works if our p is equal to 1. That is this, brother. Yes. So if I change any other value of that p, if I take any other value of p except 1, then I can use the Dirichlet theorem. So it's the Dirichlet ratio test. But if for this one, this harmonic series, the Dirichlet ratio test is not suitable. Now let us discuss an example from Dirichlet. Example 1. Question says test for the convergence n is equal to 1 to infinity minus 1 raised to power n minus 1 2 raised to power n all upon n squared by the this one's supposed to be the Lambert ratio test. Yes. We want to use the Lambert ratio test to test for the convergence of that series. What we need to do, this is our UN. Okay. Let me just write it this way. Let me call that one our UN. The solution is that let UN equal to minus 1 raised to power n minus 1 2 raised to power n over n squared. Then my UN plus 1. What is there that anytime, any place, either is in power or denominator, anywhere I see n, I will add 1. Then this one will give me, if I add 1 to this one, will give me minus 1 raised to power n. 1 n minus 1 plus 1. This minus 1 will go. I will have n. 2 raised to power n plus 1 over n plus 1 raised to power 2. Can you see? Every n increases by 1. Now, if that is the case, then what is un plus 1 over un? If you like, you can put the absolute value initial. If you like, you can do it without absolute value. Then later, don't forget it, but it's very good you put it from here. Now, I want to divide this by this. But don't forget, on dividing this by this, just like multiplying this by inverse of this. Multiply this by inverse of this. That is why I will write my own function as minus 1 raised to power n, 2 raised to power n plus 1 over n plus 1 square times n square over minus 1 raised to power n minus 1, 2 raised to power n in the absolute value. So if I multiply, that one will change. Then this one will be equal to, I want to expand all these things so that if there is something from numerator that can divide denominator here and so on and so forth. Don't forget, this one can give me 1 minus 1 raised to power n. 2 raised to power n plus 1 by law of indices means 2 raised to power n times 2 raised to power 1. This one means 2 raised to power n times 2 raised to power 1. Divided by, if I open this brother, or let me leave it like this for now, multiply by, this one will give me n squared divided by, if I come to this place, it will give me minus 1 raised to power n times minus 1 raised to power minus 1. And 2 raised to power n. 2 raised to power n and 2 raised to power n here. N raised to power minus n raised to power 1 minus n raised to power 1 here. All this one will go. Then I will have 2 times n squared divided by n plus 1 squared. Yes, in the absolute value. Don't forget, minus 1 raised to power minus 1 is equal to 1. This thing will give me 1. all this will give me 1. It will give me 1. So if that is equal to 1, then from there, don't forget, don't say it's negative 1. No, the absolute value is there. It's positive. Then from here, I can expand this denominator. I will have 2n squared divided by n squared plus 2n plus 1. If I multiply this one, it's n squared. Multiply this, that's n times 2 plus 1. Then I will get that. Now, let me take the limit. Limit n tend to infinity over 2n squared over n squared plus 2n plus 1 now. Don't forget, I said whenever you are taking the limit of a function n or x to infinity, what you need to do is to divide every term by highest power of n. Since we are taking the limit of this n now to infinity, we are going to divide every term of this function, each of them, by highest power of n. The highest power of n here is n squared. So if I divide n squared here, this one will remain 2. If I divide n squared here, this one will remain 1. If I divide n squared here, this one will remain 2 over n. Why this one remain 1 over n squared? So I will just write that one. Yes, from there, I have that one to be equal to 2 over 1 plus 2 over n. I have not used my limit. N tends to infinity plus 1 over n squared. Yes, plus 1 over n squared. If I have this one, if my n tends to infinity, this one will be 0, this one will be 0. Then I will have 2 over 1 plus 0 plus 0, which is equal to 2. So, since it means, okay, let me write. It means un plus 1 over un in the absolute value is equal to 2. And this 2 is greater than 1. Hence, the series diverges. The series diverges because this value is greater than 1, and that was the theorem. If it's greater than 1, it diverges. Now, let me look at another example there. Let me look at another example there. Okay, show example 2. Show that the series k is equal to 1 to infinity into 1 over k factorial converges. Yes, converges. Before we continue, let me remind us on something. Don't forget factorial. The factorial concept. Don't forget, if I have 5 factorial, is sequential multiplication of 5 from 5, 4 to 1 is 5 times 4 times 3 times 2 times 1. If I like, I can write this one as 5 times 4 factorial if I want to stop there. If I like, I can write 5 times 4 times 3 factorial. I can write anywhere. But what it means is that, look at the first number here is 5. The next one reduced by 1. The next one reduced by 1. I will use that experience here. By the time I start decreasing it, then you will see. Now, let us go to the solution. Let our AK, let me call it AK, is function of K, equal to 1 over K factorial. Then, our AK plus 1 will be equal to 1 over k plus 1 factorial. Yeah, if I add 1 to k. In that case, what is the absolute value of ak plus 1 over ak? I want to multiply this, divide this by this. It's like I want to multiply this by the inverse of this, which will give me 1 over k plus 1 factorial times k factorial over 1. Yeah, k factorial over 1. Yes, what I will do now is that I want to restructure this one. I want to shrink it to the way, in a way that this k factorial will come out of this brother. And that's where I will use this experience. This thing, this brother, I want this to come out of it. If I want to multiply this, I will multiply this by the next one will reduce by 1. Then it will change to 1 over k plus 1 k factorial times k. The next one will be k minus 1, but I want to stop at k factorial because there are many of them. Times k factorial over 1. K factorial and k factorial will disappear. Then this one will give me 1 over k plus 1. 1 over k plus 1. Now I will take the limit. If I take the limit of k to infinity, I'll take limit is equal to limit k tend to infinity of 1 over k plus 1. If my k tends to infinity, what will this one be? This one will be equal to 0. Or let me say this is equal to 0. Therefore, the absolute value of ak plus 1 over ak is equal to 0, which is less than 1. Hence, the series converges. So the series converges because that is less than 1. Yeah. Let us move further and look at this very important question, example 3. Investigate. Now, we want to do the police work. We want to investigate the convergence or otherwise of the series. Investigate the convergence or otherwise of the series. The series is x plus s squared over 2 factorial. Is it that? Plus s cubed over 3 factorial. Plus so on and so on to be somebody will think very well. This is expansion of sine and cos. Okay, this one is cos. That is exponential, and this one can be written as n is equal to 1 to infinity. Is it n this way? Of x raised to the power n over n factorial. X is just a number. If my n is 1, I will have x over 1 factorial. If my n is 2, x squared over 2 factorial, and so on and so forth. That is the meaning of this, brother. So we want to test, investigate the convergence or otherwise of that series. Now we have, let me call this one un to be equal to x raised to the power n over n factorial. Then un plus 1 will be equal to x to the power n plus 1 over n plus 1 factorial. Can you see? It's one-way traffic. You just go one way, you are there. Then, let us look at the absolute value of un plus 1 over un. It's like I want to divide this by this. Then I will multiply is x to the power n plus 1 over n plus 1 factorial times n factorial over x to the power n. Just like that. Then I will expand all this and this in factorial. This one is equal to x to the power n multiplied by x over n plus 1 n factorial times n factorial over x to the power n in the absolute value. X to the power n will take away x to the power n. N factorial will take away n factorial. Then, from that, brother, I will have my function to be x over n plus 1 in the absolute value, which is simply equal to x over n plus 1, the positive value. Then take the limit. N tends to infinity of x over n plus 1. If n tends to infinity on this, brother, all this denominator will be infinity. This x is a number. No matter how big x is, it can never be infinity because it does not have a limit here. So if x now is a number put on any infinity, then it will tend to 0. I didn't say it's equal to 0. So it will tend to 0. Since it tends to 0, it can give me that the un plus 1 over un is equal to 0 less than 1. Hence, the series converges. And we are going to put full stop there for brother Dan Lambert. And let me let us go to the nth root test. The nth root test. The nth root test. The nth root test. What is the meaning of nth root? It's like you want to take the square root of a function. Yes, the root of a function. If I have, don't forget, if I have x to the power 1 over n, the same thing as nth of x. Yeah, but I will not take the root. When it is written this way, then I know it's nth root. But what I will do is this. If I'm given a function of x to the power n, then I can put my nth root on this function. This one will not raise to the power 1 over n. So in this function, I can determine the value of x. If I have this, I can do it. It's very easy. This one will just go for this. Then answer is equal to x. But it's more than that on what we want to discuss. Let us look at it. Yeah. I just explained what the nth root means for us. Then, if we find the nth root and it's less than 1, if it's less than 1, we say it is converges. If it is greater than 1, we say it is diverges, just like before. Okay, let us look at an example. Investigate the convergence or otherwise of the series 1 is 2x x squared 2 x raised to the power 3 x raised to the power 4 and so on. But I will give some condition. X is an integer. It means x is a whole number. It can never be rational. It can never be real. It's a whole number, either positive or negative. So x is integer, and x can never be equal to 0 or 1 with the head of the nth root test. Yes, I want to use nth root test. Look at the conditions given to us. The condition given to us makes this thing possible for us. Once x is equal to 0, I will have only 1. Then the function will be equal to 1. Whatever the function tends to, the function will be equal to 1. Once x is equal to 0. But if x is equal to 1, I will get a scalar quantity which is greater than 1. Which is greater than 1. Because even if x is 1, don't forget this one will be 2, this one will be 1, this one will be 2, this one will be 1, and so on and so forth. Then the function, if I add everything together, it will be greater than 1. Then I don't know what that one will be, because it will be a very big number. So what I want to do here now is to use the nth root to test for that function. But before we go, let me open our eyes to something. Look at how the series was written. The first term is 1. Do you know what happened to this first term? Is because x raised to power 0. It's because x of this first term raised to power 0. Don't forget 0 is an even number. We assume that. So we call it natural, but here is an even number. Look at here, x is 1 raised to power 1, but beside x there is 2. Look at this one, x raised to power 2, the coefficient is 1, like this. X raised to power 3, the coefficient is 2. You will discover here that every time where the power of x is odd, then there is 2 as coefficient. And every time where the power of x is even, there is 1 as coefficient. So in that case, I will divide this series in 2 ways. When x is even, when x is odd. And that thing, as simple as that, it will blow out. Solution. We have un to be equal to 2x raised to power n and x raised to power n. This one, if n is odd. This one, if n is even. But don't forget, for two of them, my n can start from 0 to 1 and so on and so forth. Yes, what have I explained here? And in that case, and what I explain, let me put the what do you call it? The nth root on these brothers. Let me put the nth root. I will not get un of n raised to power n will now be equal to 2x raised to power n into 1 over n and x raised to power n into 1 over n. This one, if n is odd. This one, if n is even. Then from that side, what will happen to my function? If I expand this one now, this is what I want to use to test the series. I want to use this brother. If I expand it here, this one will give me this. 2 raised to the power 1 over n multiplied by x. Don't forget, this one will come on this one will come on this. And what is come on this, it will remain there. But if 1 over n comes on x, n raised to the power n, this n will divide this n, it will remain only x. The same thing here, it will remain only x. But if I want to finish it, because I need a positive value, let me put the absolute value of x. If n is odd, if n is even. Yes. Come back to this place. Before we write the final answer, look at, if n tends to infinity in this brother, what would this one give me? That is the problem. This is x, positive x. This is positive x because of this absolute value. X. But I want to know, are they going to give me the same value? Oh, no, my problem here is 2 raised to the power 1 over n. But don't forget, the limit of my n must tend to infinity. Can you see? It tends to infinity. Set to infinity. Now, if my n tends to infinity, what would this one give me? This one will give me 1. If my n tends to infinity, this one will give me 1. Because it can never be 0. That one will give me 1. So if that is the case, I will now say this function is equal to absolute value of x for both cases. Since 2 raised to the power 1 over n, let me write it as limit n tend to infinity, then 2 raised to the power 1 over n will be equal to 1. That one will be equal to 1. Therefore, the series yes, look at the value of x. Come back here. My x can never be 0. My s can never be 1. It means the next value I can take for x, because x is an integer, then the first value I can take for x here is 2. 2, 3, 4, 5, and so on and so forth. It means the value of this function of this brother must greater than 1. Since this value is greater than 1, then the series diverges. And I say, therefore, the series 1 plus 2x plus x raised to the power 2 plus diverges. Diverges. Since, I will write it here, the absolute value of x is greater than 1. For all x except at x is equal to 0, 1. So, and my x cannot even be equal to 0, 1. So in that case, I want to give exercise. Yes. Write it at home. Do look at it very well. Then, before we meet next time, let me write the exercise here. The exercise says, verify that this one k is equal to 1 to infinity of 1 over ln k raised to power k converges. Number 1. Number 2. the sum of k is equal to 1 to infinity 2 raised to the power k over k raised to the power 3 diverges. Okay, using nth root test. So, and from that one, I'm going to call it a day till we meet next time. I'm very sure when we meet next time, then we'll round up the chapter 2 of the book, and we'll have only chapter 3, which is as well very big, but we pray God will help us. Thank you. God bless you.
Finish him. Kill the guy now. Round the corner.
What? What is this?
Good day, sir.
You are watching Jakepan in my house.
No, it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you'll be fighting kung fu in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have it last semester.
We by pounds on you. Very stupid. We are changing that section to ACTV right now. And oh God, the baby wants to have been first born. Stupid boy.